sometimes for some reason, if I start a second video or the third or next video, it just has a glitch. So I'm going to just say this one more time. So this is the accumulated interest, accumulated amount, principal 1 plus the interest rate divided by the number of times we compound the interest per year, and n times t is n times the number of years. And this is for the continuous compound interest. Principal e to rt, interest, annual interest rate, number of years. So for the principal interest rate and t calculated quarterly, we have this to plug in the graphing calculator. Don't do it step by step. Enter the whole thing as you see it. And this is for the interest compounded continuously. And now, if we're asked, for example, to double the investment, find t so that the investment doubles. This is still an algebra situation. Your investment doubles, meaning 600,000. We started with 300. We want to know how many years we need to see our investment doubling. So equals 300,000 and e to 0.022 times t. So in this equation, we don't have t. We want to find how many years we have to wait for our investment, our principal of 300,000 to double. And of course, you have to divide both sides by 300,000 and you get 2 on the left, and then you apply natural log as we did. So simplify, so 2 equals e to 0.022 t, and then we apply natural log to both sides. The left-hand side is natural log 2, and the right-hand side is 0.022 t, and of course we divide this by this. And we determine the number of years required for our investment to double. Any questions on this? Any questions on this? Now we can consider that we also discussed implicit differentiation, because these are very similar, unless you want to go back to that too.
We look at one of the d-test problems with the 2 variables.
Yes. Yes. I like that. I think that that's really fun. Yes. And they are in chapter 6. Of course, in 6.3. So that's 23. Good. Let's say, I don't know, problem 11 on 576. I highly recommend look at the solutions to all our homework, written homeworks. Okay, so we have to find fx, which is 2x. We have to find fy, which is negative 2y. We have to find fxx, which is 2. We have to find fyy, which is negative 2. And we have to find fxy. Fxy is 0. And fyx has to be 0 as well. So now we have to find, we have to create the system fx0 and fy0. So 2x equals 0 and negative 2y equals 0. Obviously, there is only one solution. x comma y, which is 0 comma 0. So let's see what happens at 0 comma 0 for this function. So the d-test states that I have to calculate fxx at 0, 0, but there is only one number, there is nothing else, multiplied by fyy at the same number, and minus 0 squared. So let me write the d-test for you again. So the d-test, let's say for a comma b, is fxx evaluated at a comma b, this is one thing, fyy evaluated at a comma b, this is another thing, minus fxy also evaluated at a comma b, but it has to be squared. If this number is negative or 0, there is no relative max min. If this number is positive, then it depends on fxx. If xxs is positive, then it's a relative minimum. If xxs is negative, then it's a relative max. But it happens for this calculation that this is negative 4. So no relative min max. Because we found d to be negative.
I have a question.
Yes.
For the part where you make the system for fx and fy,
Yes.
if I ran into an issue on one of the problems I was doing where I had both variables in each part, so like fx included x and y.
Yes. Can you give me the
solve for
problem?
that?
Yes. Yes. Do you remember the problem? Very good point.
Let's see if I can.
Please do. So
If you
again,
want to go on to something else, it's going to take me a minute.
that's okay.
I'll take a minute.
No, I still want to just give the full test here. So if d is negative or d equals 0, no relative max min. And there are two options for d being positive. If xxx is positive, it's a minimum, relative min. If xxx is less than 0, it's a relative max. So this is the whole test. Easy to remember. So we calculate d for each critical point. If d is less than 0 or 0, nothing. If d is positive, there are two possible options. Then I have to look at fxx. If xxx at that point is positive, then it's a relative minimum. And if it's negative, it's a relative max. Exactly how we had it with the functions of a single variable. Very similar.
I have the problem if you're ready.
I am ready.
It's fxy equals x squared plus xy plus y squared minus 10y plus 33.
Let me repeat. F of x comma y is x squared plus xy plus y squared minus 10y plus 33.
Yes, ma'am, that's correct.
Okay, perfect. So let's find fx, which is 2x plus y. Let's find fy, which is x plus 2y minus 10. Let's find fxx, which is 2, fyy, which is 2, and fxy, which is 1, and fyx, which is 1. Perfect. So now we have fx and fy set equal to 0. It's like with critical numbers from functions of single variables. And we have 2x plus y equals 0. And we have x plus 2y equals 10. Because I moved 10 to the other side. I remember the problem. If you remember what we did, we solved this equation for y. So y equals negative 2x. And we plugged it in the second one. So we have x minus 4x equals 10. And then x minus 4x is negative 3x equals 10. So x equals negative 10 over 3. Ugly, but that's the situation. I have to find y. So I have to multiply this by negative 2. So then y equals 20 over 3. So the critical point is negative 10 thirds comma 20 thirds. Okay, let's recap. Let's go back slowly. So when we differentiate this function with respect to x, we have 2x and we have y. There is no x here. When we differentiate with respect to y, there is no y here. There is a y here, so I have x. There is a y here, so I have 2y. And there is a negative 10. That's negative 10. When I differentiate fxx, I differentiate this with respect to x again, I get 2. When I differentiate this again with respect to y, I get 2. And when I differentiate this with respect to y, I get 1. When I differentiate this with respect to x, I get 1. Then we create a system. Fx equals 0 and Fy equals 0. 2x plus y equals 0 means y equals negative 2x. X plus 2y minus 10 equals 0 means x plus 2y equals 10. I replaced y by negative 2x. Negative 2x times 2 is negative 4x. X minus 4x is negative 3x equals 10. So x equals negative 10 thirds. When I multiply negative 10 thirds in here to find y, by negative 2 I get 20 thirds. So the point in discussion is negative 10 thirds comma 20 thirds. Is this okay?
Yeah, I'm good now.
Perfect. So should we continue with the D test?
But really, the only part I was having trouble with was I
Finding the
didn't
C.
think to use the substitution. Yeah.
Okay. Okay, very good. 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 Next question.
What is 11, 12, 13? I can't see.
Oh, yeah. So in 11 is differentiate a product, ratio, power, and the chain rule. 12 is finding increasing, decreasing intervals, and concavity intervals. Concave up, concavity intervals.
Okay, can we do 11?
Yes. So what do you prefer? A product, ratio, power, chain rule?
Chain rule.
Okay. So here's an example for the chain rule. I lost track of my page numbers. Okay, so this is 7. So I'll give 2 examples with the chain rule. So for example, natural log of 2x cubed minus 2x plus 1. And the other one, another example, let's say f of x equals the square root of 4x squared minus 3x plus 1. So both are examples of the chain rule because I have a function inside another function. I have a function inside another function. So when I differentiate the first one, I have 1 over 2x cubed minus 2x plus 1 times the inner, the key is times the inner function prime. So this is 6x squared minus 2. And there is nothing else we need to do here. So when I differentiate a log, is 1 over the function times the inner function prime. Now here the same thing, f prime equals 1 over 2 the square root of 4x squared minus 3x plus 1 times the inner function prime, 8x minus 3. And this is it, times the inner function prime. I'm kindly asking you to redo all the problems in the last week and a half from the reviews, all the problems from the previous tests, and review your previous tests, please. You know how to get to review and click on review the previous test, right? In the grade.
A question.
Yes.
It wouldn't let me like go into my test.
Go back to Pearson, not Canvas, to Pearson, and in the left column somewhere you should have a link that states gradebook. See
yeah,
if you
see
can.
that.
And now when you click on that, you should be able to click on any of the tests to review your test.
Oh, I see. I see.
Does it work?
Yeah, it lets me see it now. I was trying to go through the assignments tab and it wouldn't let me see it through there.
Okay.
Okay, thank you.
Yeah, of course they're open to you. Good.
We look at 22.
22. Domain of, yes, very good. Allow me 1 second to put the attendance in. Very simple. Isaac is here. Shauna is here. And George is here. Everybody else is not. Okay. That is done. Perfect. So here's an example. Let's say I have f of x equals e to the square root of 2x minus 3y. The only thing I have to write is the 2x minus 3y. Since it's under a square root, it has to be greater than or equal to 0. So when I write the domain, that's all I have to write. That consists of the ordered pairs such that 2x minus 3y greater than or equal to 0, and this is it. I don't have to do anything else. On this page, we only have derivatives left, continuity at this point, and reading from a graph and evaluating. derivatives, continuity at a point, reading from a graph, domain, range, and limits, and evaluating this function.
Can we just look at some derivatives?
Yes. So we looked at the chain rule, so I'm just going to create a product for derivatives. Okay, because we looked at two functions. Okay, so here's an example. Let's say f of x equals 2x to the third minus 7x plus 1 times e to 3x. So of course I have to immediately understand or realize that this is the product rule. I have a product of two functions, and I have to use the product rule. So then f prime of x equals the first function prime, 6x squared minus 7 times e to 3x, plus the first function, 2x cubed minus 7x plus 1, times the second function prime, which is e to 3x, times the inner function prime. And you can leave it as is. It would be nice if you would factor out e to 3x and combine like terms. So that would be the nicest thing to do. So e to 3x, and then 6x squared minus 7 plus, don't forget to multiply by 3, 6x to the third minus 21x plus 3. And combine like terms. So this would be nice, to realize that both pieces, both terms have e to 3x in common, and factor that out and simplify.